All right, so we're talking about inheritance today. Yesterday, y'all learned about modules, which is one technique to kind of start like sharing code. And today we're going to be talking about the other, which is inheritance. And today, at the end of today, we're going to see like why inheritance is one of the essential. We're going to see that it's one of the essential principles of object-oriented programming. We're going to talk about what it is, and we are going to use it. Like I'm going to show you some stuff. You're going to do some stuff. And you're going to see that you can do some overwrite, some local methods. We're going to talk a little bit. We're going to touch upon the inheritance lookup chain, and we're going to write some code that shows the single inheritance principle. So to warm up, where's my I'd like you to look at these questions here and take about 5 minutes. It's a little bigger. And answer them in your notebook, and we'll talk about these. Let's give you 7 minutes. Let's take till 9:10 to answer these questions in our notebooks. Take about another minute. Cool. So Leah, what functionality did modules give us? I asked Leah.
Modules,
Yeah.
ability to
Yep.
like share methods across classes or behaviors.
Cool. Corey, what do you think of when you hear the word inheritance?
I said I think of gaining a trait or functionality.
Cool. I would have also accepted Paris Hilton. I think that's appropriate.
Good old PT, perhaps.
Yeah. And so just open it to the crowd. Like anyone can chime in. Where do you think we get the ability to call the methods add a reader or assert equal? Where are they defined?
Mini-test.
But what about add a reader? Where do we think that comes from?
They're module objects
But from where?
from Ruby.
Yeah. And so, yeah, they come from like, for lack of a better term, modules above. And we're going to talk about how that kind of happens in a little bit. But when we talk about inheritance, right, let's, right, the idea is that it's one way in which we can use code defined in one class in multiple classes. And the technique that we use in inheritance is like this idea of a parent and child setup, where when we define methods on the parent, we can then use them in child's children. You get the idea. And so the technical definition, according to Sandy Metz, in her book, Practical Object-Oriented Programming in Ruby, let's make this a little bigger. Inheritance at its type today core is a mechanism for automatic message delegation. It defines a forwarding path for not understood, what's that last word? Messages. And just like messages, like what are messages? We're going to talk I've been dealing with methods, but this will come clear in a little bit. And the thing is that we've already seen inheritance, right? Whenever we write a test, it's something like class pizza. Oh, no. Fries test inherits from mini test, right? The fries test class is inheriting from mini test. And, you know, in the snippet above, it's this portion here is saying like, hey, I want my fries test class to inherit the characteristics and behaviors from the test class of the mini test module. This is not the same thing as when we mix in a module, as you saw yesterday. This is something called namespacing, which we'll talk about a little later. But as with everything in Ruby, there are rules. I should probably ask, y'all can see my screen, right? I'm just not typing notes here. Okay, because I just realized like I've been typing these notes here and would not be helpful if you didn't see it. And I'll take this and I'll paste this into your Slack channel when we're done, so you have it. So the rules: 1, objects modeled using inheritance must demonstrate a generalization, specialization relationship. This means that when we set up inheritance type relationship between two things, one has to be a general, one has to be specialized. For example, we could have a general class called mammals that have all the stuff that all mammals have, and then we have a human class that inherits from mammals, where humans have all the methods and behaviors that are specific to humans, but they also get all the stuff from mammals, things that all mammals have. For example, like I could potentially, in the mammal class, I would put things like breathe, right? Because all mammals breathe. I could put a method called have hair. Mammals have hair, right? All mammals have hair, right? If not, let's just say they do. Whereas a method in the human class could be critical think. I don't know. Oh gosh, now it's like, how do you define a human? But
Opposable thumbs.
are humans the only mammals that have opposable thumbs? Don't certain apes do?
Maybe.
Maybe. Well, we'll just say that only humans have opposable thumbs, but like you get the idea. Things that only belong to humans belong in the human class. Things that belong to like all mammals would go in the mammal class. Cool. When a class inherits from another class, it receives access to all the methods and instance variables from that other class. Right? Kind of like makes sense. When I inherit from another class, I get all the stuff in there. I don't get piecemeal. Because when we think about like, how do we define the distinction? How do we say, like, well, I'm only going to have these methods and attributes? Like, no, you get all of it. The inheriting class is called the child or subclass. I think that makes a lot of sense if we're going with like the Paris Hilton model of object-oriented programming. The idea is that the younger or the smaller, the specialized object gets everything from the generalized object. The class being inherited from is called the parent or superclass, right? We're just defining terms. I think this is important. This is like we kind of touched this briefly above when we say that we are talking about the single inheritance principle. A class can only inherit from one parent. A class only has one parent. You cannot have a class that's grabbing stuff in from this and this. Like this muddies the waters and makes things very complicated. The chain of parents, and so forth is called its ancestors. This demonstrates is that we can have a literal chain of things. Like my one class here can inherit from its parent class, and that parent class can inherit from that class, and so forth. Right? There's a whole chain. Everything up the chain is referred to as an ancestor. And any number of classes. Ooh. Any number of classes can inherit from single superclass. An example of this is that for mammals, what other mammals? We have the human child class. We could have dogs, cats, bears. These are all things that can inherit from that single superclass. And to kind of like, when we think about it, we could potentially have like, for a dog class, that then could have its own child classes. Like say we could have a Corgi subclass, we could have a Husky subclass, and then when we think about that, that Husky subclass its ancestors are the mammal superclass and its superclass. I'm sorry, the dog superclass, and then the dog superclass, which is the mammal superclass. Like we can create this whole hierarchy of things. And Sandy Metz kind of puts this into like this practical use. Like when we think about bicycle behaviors applies to all bicycles, some only to road bikes and some only to mountain bikes. The single class contains several but related types. And the problem here is that this is what we're trying to solve for, that highly rated types that share common behavior but differ along some dimension. Right, so we can imagine this thing like, okay, do we create a road bike class and a mountain bike class? Well, the idea here is that like, well, there are some things that these two objects have in common. They're all going to have the same number of wheels. They're all theoretically, have the same number of pedals. So why not have a bicycle class, and where things differentiate, that's where we create subclasses for. Cool. Any questions about the rules or anything like that, or stuff like that so far? We've been talking mostly about theory so far, but I think that it's kind of a good thing to do to kind of show you how this works in action. Right. So can you all see my editor okay? And my terminal? Cool. I've created the files ahead of time, and I made this employee object, this employee file, and we're just going to make a basic, let me make that bigger. Is this cool? All right. We're gonna make a class. And just a employee, and has a total compensation, which adds the base salary attribute and adds the bonus, right? That's how much an employee would make in a year. So then we are going to make a CEO object here. And the first thing I'm going to do is that I'm going to make CEO inherit from employee, because after all, is not a CEO an employee? And so we're going to do require, right? Going to need to tell where it is. And then we're going to do this, class CEO inherit from employee. I'll make this a little smaller so I have a little more room. Is this still okay? All right, cool. Okay. And what I'm going to do is that I'm going to make a runner file. And that's just going to do, it's going to require CEO. Whoops. And their base salary is going to be 15 ducats. And their bonus is going to be 20 ducats. And puts it's going to put the total compensation. And what this does, we're going to run this. Runner. We see it prints out 35. So we can see here, because through the mystical powers of inheritance, even though we have not defined a total compensation method here, the CEO still responds to this method because it inherited from employee. In this particular example, the CEO is a subclass or child object, and the employee is the superclass or parent. Any kind of questions about what I've done so far? I should probably move the window so I can see if there are any hands. Yeah. An important thing to note is that I think that a common fallacy that people that are new to learning inheritance have is that you think that, oh, my employee class is passing down this functionality to the child. But this is the exact opposite of what's happening. What's happening here is that the CEO is looking up. So when we run, we have here, we've instantiated Ali is a new CEO, and we run, hey, I would like to run the total compensation method on Ali. Well, Ali is what class is Ali? It's the CEO object, right? So when we look at the CEO object, it's like, okay, all right, I'm going to look for a total compensation method. Do I see a total compensation method inside my CEO object? I do not. So because we are doing this here, inheriting from employee, the next step is that it is going to say like, okay, I don't see that method here. I'm going to go up and I'm going to go look at the employee class, which is my parent class. And when I see that, I'm like, oh, employee, I have total compensation. I'm going to run that now.
Hey, Mike.
Yeah.
So is that logic the reason why you have to do an adder reader for CEO rather than for employees? Because CEO is looking up.
I don't understand what you're asking. The adder reader for these, just as a force of habit, like those are things we want to access outside. Like if we did this, this should still work. Oh man, I cannot type today. Save. Adder readers are just letting us call the methods without hitting the instance variables directly. Like I could take this, like I showed you, I can take this out. All this does is that, like, when we're inheriting, all we're saying is like, hey, if you don't find the methods I'm looking for now, you go up one step and look for it there, right? In this case, we are just using adder readers, the idea is that, like, these are attributes of CEO, and if we're building a system out, we probably want access to that outside, but it's not necessary.
But why is it that you have to initialize in CEO but not employee?
That's just a design decision that we've made. I think that, like, when we look at this, right, when we build this out, we are never going to have just an employee. It's always going to be like a specialized type.
But in theory, you could initialize an employee.
Yeah, in theory we could,
Okay.
but don't. Like the
when
idea.
when would you want to inherit or just use a module?
It depends. I think it depends on your design and your structure, and how you want to do it. The use, like, I think for a lot of you that I talked about Battleship with, like a good usage of the module there was for like the messages, like everything that prints out the screen, we could pull that to a module and share that across everywhere. I think that when we want to use inheritance, the better use for that is that when we want to deal with state, when we want to deal with behaviors. That is stuff that I think that my usual line is that, one, if there's behaviors involved, is probably when I start thinking about inheritance. Also, when I start thinking about like the structure of things, right? Like here, I'm modeling employees, and the kinds of employees have a little differentiation. This is when I would reach for inheritance. I think that if I just want to share code, my first reach would be a module. If I just had just some methods I just wanted to reuse, I would reach module. But like the inheritance is a step I want to take when there's like kind of there is a structural organization aspect to it as well. Because like for like this example here, we have an employee and a CEO kind of employee, and a little later on, we're going to add some more different kinds of employees. And that's when I would start reaching for inheritance instead. Does that answer your question?
Yeah, thanks.
Mm-hmm. Cool. All right, so let's take a breather here. Let's be back at 9:35.
Thank you, 9:35.
Let's kind of like go back over what we're doing here. And so creating a sales manager class and Hertz employee, check. Takes base salary, estimated annual sales as argument to initialize. Cool. So let's initialize, and what was that? Base salary, and estimated annual sales as arguments. Cool. So we'll just do the thing. Base salary equals base salary. Estimated annual sales equals estimated annual sales. And because I am that person, cool. Create a bonus method on sales manager that returns 10% of estimated annual sales. Cool. So bonus, 10% of it. So that's estimated annual sales times 0.1. Cool. That's 2. Create a new sales manager in my runner file and print the total compensation to the terminal. Cool. White equals sales manager.new. Base salary 10. Estimated annual sales 20. And I'm going to have to require manager. That should work. And oops. Cannot load file sales manager RB. That's because I'm missing a period. Unexpected dot. These in parens. It gets confused because the dot usually means that we are looking for a method, but we just want to like say it's a decimal point. No,
I think you just put a 0 in front of the dot.
that may do it. Yep, that's probably it. Let's try that. Cool. 35. Well, actually, I didn't print anything. Puts Dwight total compensation. Unknown base salary. Yep, that's because I didn't have to add a reader. And 12.0, that seems reasonable. Luke?
Just so I've got it clear, the employee is the parent and sales manager is the child.
Yep. Yes. Cool. So this should match up pretty closely what you have. Where are we? Cool. So the next thing we want to talk about in our journey of learning about inheritance is super. And the idea is that we have this key, when we inherit from things, we have this keyword called super, and it calls the method from the super class of the same name. So like if you use super inside an initialize method, it'll call super from the parent's initialize method. Super is just like a really kind of word. And I think that what we say to think about is a call parents method, right? So what we're going to do is that, let's say, the example we're going to use, like, let's say that we want every employee to have a name and ID, right? And so because we want every employee to have a name and ID, we're going to put this code in the employee object, employee class, right? It's not a situation where like, hey, we want to, like, we only CEOs have names. Like that's kind of one shitty. Two, like from programmatic standpoint, it doesn't really make sense. So what we can do is that in our employee, ID, have that in there. And what we would have to do is that we have to make changes in our CEO object because we're just going to work with the CEO right now. The CEO object is now going to take a name and ID. We're going to put this at the end. Oops, no. Oh boy, typing is on point today. Have that tick there. And then what we would do here is we do super name ID. What's happening here is that we initialize a CEO object and we give it a name and ID. In addition to this bonus, the base salary and the bonus salary. Base salary gets set to an attribute inside the CEO. Bonus gets set to an attribute inside CEO. But because the name and ID belongs to the employee superclass, we're going to use super. It's like, hey, go grab my parents' initialize method and shoot these attributes in, the name and the ID. Questions. This super here, because it's in the initialize method, is calling, let me get rid of, pull this down a little bit. Because super is running it inside this initialize method, it's like, hey, I want you to hit the initialize method of employee because CEO is inheriting from employee.
I got a question.
Yeah.
So the reason why you couldn't call name and ID within the CEO file is because you can't just call name and ID in the initialize within the CEO file without
Well, you can.
super.
You can. Like
So
if
why
I
use
an,
super?
an alternative is that I would have at name equals name, at ID equals ID. That we can certainly do that, and that will work. We're using super because like we want this to live in the employee object because all employees are going to have a name and ID. Not all employees are going to have a base salary and a bonus. It's a way of like essentially a way of drying your code up. Like this is kind of shortcut. Like, hey, I want my parent class to handle this stuff because all employees, like we're trying to cut down repetition. Like it doesn't make much sense when we just have the CEO employee, but we're going to do this in a little bit. Is that like, what if we have, like, what if we, so like we go over to sales manager, right? Let's say sales manager now takes the name and ID like that. We would then do super name ID rather than doing at name equals name at ID is there again. Like we want to push that over to the employee to kind of like cut down repetition, right? Like for, yeah, you was, yeah, but it's only two things. Like, well, yeah, this is only two things because this is a kind of a small example that we're going to fit into a 2-hour class. But, you know, you can probably imagine like, well, what if there's a lot of stuff? Like when you get on the job, how much information do you think, you know, your employer is going to have on you? Like name is probably going to be something that belongs to an employee. ID, yep. Address. Every employee is going to have an address. Like the attributes you can think of that that a potential employer is going to want to track is like countless, and this will help us cut that down. Cool, Phil.
Wouldn't every sales manager that you make then have the same name and ID?
No, because we pass it in when we create it here.
Okay.
So this would be like, so like if I were to make that change in our runner, this would be Ali ID 1 because they're the CEO. This would be Dwight and 2. Like each thing here is still a separate instance of. We're still creating a separate instance of each thing. No, we're not sharing values among the things. Each is still a different instance, and they still have separate attributes. It's just the methods and the behaviors inherited, not the actual contents of the attributes.
So you're essentially like extending the initialize method?
Yeah, I think that's a way to think about it. Yeah. Luke?
So super is like a native Ruby method to do that? Okay, cool.
Yep. It's just like, I think the good word for it is like, it's a keyword. It's like, hey, this is a special word and this is what it does. Right. So there are a couple of ways to use super. One, super this is the syntax that we used right now, calls the superclass method with arg1 and arg2 specifically. 2, just super, calls the superclass method with all of the arguments in the current method. Like it takes everything that's coming in and just shoots that over the superclass. And 3, super, by its super with the parens, by itself like this, calls the superclass method with no arguments. So those are 3 potential uses. Okay?
I'm wondering, like we've been having a lot of conversations about like performance, right? Like how would you describe that superclass makes our code more performant?
I would not say it makes it more performant. I would not say that. I think that it provides a structure and provides a it dries up your code, which makes things smaller. I guess it makes performant in that way because your project's literally shorter. I don't think that it is inherently something that enhances performance. I think it's something that is a human thing to it. Whereas like I can look at this and I'm like, okay, so I get it. A CEO, a sales manager, whatever, these are employees. I understand that like, hey, if I'm looking for a behavior that's applicable to all employees, I'm going to look at the employee class. It provides us, I think it provides us a mental hierarchy in which we can think about things. And I think that's one of the probably the second, I guess you could argue like what is the greater benefit of using inheritance. I think I personally feel that the hierarchy that it provides me is the real benefit of inheritance. I like the dry stuff. Yeah, like you can like if our main goal was to dry stuff up, we would use modules, right? The idea is that the hierarchy gives us other side benefits, other alternative benefits to this.
So in the same ways that like we can only use modules to dry up behaviors, hierarchy is a model to dry up state within our classes.
Also behaviors too. Yep.
Also behavior, okay.
Mm-hmm. Right, because you can have methods that do things like if I wanted to, you do def piss off puts I quit. Right? And that's a behavior that is now shared across all employees. When you piss off an employee, they quit.
Okay, that's helpful. Thank you.
Yep. Leah?
What if employee had attributes or a class that it was inheriting from? And would you do like a super there too?
If I needed to.
Okay. So like
yeah.
Does a child kind of look up the chain of ancestors to infinity until it finds what it's looking for?
Yes, exactly. Okay. I think a good way to think about it is like we can also take this to like kind of another level. Like remember when we were talking about scope, how we have this kind of progression which way we look things up. And so the idea here is that like, let's say in sales manager, I needed total compensation. Right? And the idea here is that, hey, I'm looking for total compensation. Is there a local variable inside bonus that is total compensation? No. Okay, cool. Now I'm going to look to the sales manager class as a whole. Is there a total compensation method inside sales manager? No. So I'm now going to go up one, which is the next ancestor, which is employee. Hey, employee, is there a total compensation method in here? Yes, there is. And so let me do this. Okay, so I have a prize session, Ally.class should be CEO. What I can do is Ally.superclass. No, wait, is it super? Oh, let me figure that out. Ruby. What is that method called? It's parent. No. Oh. Ally.class is CEO, Ally.class.parent. There we go. You actually have to call on the on the thing. So I can see that when I get Ally.class is the CEO. That class's superclass is employee. So if I do this, what do I get? What do you think I get?
There's no, it's not inheriting from any other superclass, and like some sort of error, or I don't know.
Object.
Oh.
And instead of basic object, and no. So like, even though we are not implicitly, employees not implicitly inheriting something, it still has like classes above it, right? That are just built into Ruby. For example, we can do this. Number one, what class is that? Integer. Numeric. Object. Basic object. All things. This is how we get like methods. If we go to our this is the documentation for the Ruby object in Ruby. And we can see here that we have methods like variables, hash, inspect, .nil question mark. And the idea is that like these are methods that everything in Ruby has kind of inherits from. So this is how we can compare things, like using the spaceship operator. If we go to, let's do Ruby basic object documentation, like equal, the double equal sign. Like this is how we, like these methods belong to everything. So the idea is that in Ruby, whenever we look for a method, it's gonna look closest and start going up the chain. When it says that it can, when it finally errors out and says that it cannot find a local variable or method named this, that means that it's gone through, let's say for a number, it's gone through, it's looked at the integer class, can't find that method, then it goes looking at the numeric, can't find it in there, and then goes to object, can't find it there, then goes to basic object, can't find it there, and then it returns to that error. Like everything has this is called what's called the inheritance lookup chain, in that it's gonna keep going up the chain until it finds it, and if it can't find it when it gets to the end, it's gonna error out for us. Cool, and we'll talk more about the inheritance lookup chain and like the Ruby object model a little, I think later this week, I think. Other questions at this point about all these wonderful new things that we're learning? Cool, let's take 5. Let's be back at 10:11. Oh, Travis. Travis. Is Travis back yet?
I am, yes.
All right.
I actually figured it out, though.
Okay. Well,
thank you, though.
There you go. You had the magic inside you all along. Cool. So,
Travis figured his stuff out. Can I ask you about a weird error I'm getting?
Is it related to this?
Well, it's with this code, but not necessarily related to inheritance.
let's put a pin in that. Let's come back to it if we have time at the end. Like, there's a couple more things I want to hit before we to make. I want to make sure a couple things I want to make sure we hit during the class. So, ideas that okay, cool. We have these things. We got all these methods. We're inheriting from employee. That's great. But what if there are exceptions to the rule? We can use a technique called overriding, which will override methods from our parent class because we're redefining it in our child class, right? And so what I'm going to do is I'm going to bring up make an intern class. Make the employee class intern. It's going to inherit from employee. And the difference between an intern and a regular employee is they're going to get paid by the hour. And they are not going to be like salaried. Nor do interns get bonuses. So def in EOI's hourly rate name ID, right? They still have to have a name and ID still because like we decided all employees are going to get that. And we're going to use super name and ID here like we've done before. And what we're going to do is that we're going to def total compensation hourly rate times $20. And so this is how we override methods, and this should make sense. Like if we can, like when we think about how we talked about this inheritance lookup chain, like from before the break, when we go to our runner file, and we're going to make what's the name of it? Ryan equals intern.new, and it's going to be hourly rate is going to be. I'm sorry, this is not 20. This is not $20. It's 2,000 hours. So let's say their hourly rate is 20. Their name is Ryan, and their ID is 400. We do puts Ryan dot total compensation. And we'll count this out. I need to require it. Cool. 40,000, which is 20 times 2,000. Yeah, that makes sense. Right. This lets us kind of like, hey, we're not going to have a base salary or a bonus. So therefore, we're not going to use these attributes at all. In fact, an intern doesn't even have the attributes base salary or bonus, but instead of total compensation being a formula of this base salary or bonus, we're going to take the hourly rate, which is an attribute of the intern, because when we think about like no other employee has an hourly rate, and we're going to multiply it by the hours worked, which is like, arbitrarily 2,000 here. But when we initialize it, we're setting the hourly rate within the intern object, and it's like, hey, just make sure we get all of our attributes settled. We'll super off the name and ID to the super class. Other questions? Cool. Other fun things that we can do is that we can combine super with overriding. This is not a one or the other kind of thing. Let's say in our employees, for every employee is going to have benefits. Benefits. And let's say that we are going to give all our employees sick leave. I think the big news was that recently Colorado voted that the sick leave was going to be mandatory for everyone in Colorado. Like, fantastic. And we have that there. And so the CEO, what we're going to do is that we're going to override the benefits, because I want the CEO to have more benefits than just the sick leave, right? And we're going to do def benefits super dot push health insurance. And what this does is that when we use super by itself, at least let's just ignore this part right here. When we just run super, it's going to go and it's going to grab the same method in the super class. So it's like, okay, I see super inside benefits. That means I'm going to go grab benefits and employee and bring that back. So now I've got this array with the symbol sick leave in it. So I'm going to then add on to that health insurance. And if I go over here, I do puts alley benefits. I should see. No, what did I do? Did I spell something? I didn't save it. That's why. Yeah. I see that I have sick leave and health insurance. Because yeah, I'm overriding benefits, but I'm also getting the original contents to override with that. Like this is a and kind of situation. Any questions about this overriding? I think that, like, again, like when we think about the lookup chain, like this, I think that, like, I use this analogy a lot. Like when you find something, you stop looking. When you find your keys, you no longer continue to look for your keys. When our intern, when we run this, we find the total compensation method. Ruby does not continue like, oh, I found the compensation method, but I'm going to go look up an employee for the total compensation method. Like, no, like it's found it. I'm going to halt here. You are like, essentially what you're doing here is you're inserting something into the lookup chain and make sure that this hits here instead. So we're kind of short circuiting the standard process. Phil?
So if you didn't have total compensation defined in your intern class, it would then go look for the total compensation up the chain. Yep. And it would throw an error because there is no bonus for intern.
Yeah. So because base salary and bonus are going to be nil, it's probably error out says like I can't, no method plus on nil is probably what it would do. Yep, it would just freak out and be like, no. So like big picture things to think about, like if you are overriding a lot of methods in your superclass, that's probably sound like, yeah, this was not a good idea. Because like, why build something that to reduce repetitiveness if you're overriding a lot? Like, so like this is something that like using superclasses and designing an appropriate hierarchy are ideas that should be done carefully and with some thoughts and planning. That being said, like, you know, like I say that like, you don't know as much about as less about a problem as you do in this moment of time. So there is that kind of balance to be struck of how you think it's going to go. And you want to strike a balance between coding too much, and two, like painting yourself into a corner, right? You want to just have enough where it gives you some flexibility, but not too much. Cool. So let's take 5 minutes and practice it. So I want you to modify the CEO to have a total compensation method there that adds $1 to the base salary before returning the total compensation. I'm going to give you 5 minutes. I'm going to throw you into the breakout groups. Let us take 5 minutes. The two things, the instruction we have is that we want to override a method and or use super so that when you call total compensation on CEO, it adds $1 to the base salary. So yeah, like because I know that base salary, total compensation is just the base salary plus a bonus, I can just call super and add a 1 to it. Like that certainly works. Or alternatively, that I can just do the math in here and override it completely. And that's like the approach you choose is probably going to be dependent on the complexity that you need. like personally, I would probably not do this because it'll make someone, if someone's trying to figure out what you're doing, it's probably going to make them go find the employee class and like, why? When I can just do that. This very much defines the requirements when asking me. I want to add $1 to base salary before bonus, and knowing that because we're just doing all addition here, we're just going to go left to right. So base salary plus 1 plus bonus. Anyone have any questions about this part here?
Yes.
Another question on, okay. Go ahead.
Go ahead, Enrique.
Thank you. We ended up making a like raise by 1 method and trying to just call it right above base salary and plus bonus and total compensation.
Mm-hmm.
And basically all I did was call on base salary and add 1 to it. But we weren't able to test to see if it would end up calculating to like the right number or
yeah, you could like that as an approach. I think that like for something like this, I probably wouldn't have broken out to a method because you're just adding 1 to it. But like, yeah, that should totally cool work. Well, who was asking the other question?
My question was on super. It's a little going back a little bit, but it's when you're using in employee, you set up name and then that one that right there. So I kind of was taking notes and I kind of missed a little bit on that, and I was trying to use it and I couldn't get too many arguments, and I was wondering if you could maybe at one point.
I don't understand what you're asking for.
So how to use super? Like in line 9, you're using super name ID.
Yeah.
In employee.
Yeah. So what super does, like in this case, what super doing is that it is calling the initialize method in employee and passing it the name and ID.
So when you create the weight in the runner, how do you pass those arguments?
Yeah, like this right here. Because it's still, this is still taking 4. We're just setting 2 of them over to, don't need that. This is going over there is all.
That's giving me, that's asking me, I may have been missing something because it's telling me that I don't have enough. I'm sending 4 and expected 2, but I'll review that later if you, seems like something small. Thank you.
There's probably a typo somewhere in your code. Cool. What other questions do we have here? Travis?
Yeah, I just want to make sure I understand this right. In your CEO file on line 8, so naming that method the same as your file 2 an employee, that overrides the superclass essentially?
What it does is that we are injecting a method into the lookup chain. So what we're doing is that when in my runner file, when I run puts alley.total compensation, we are going to hit the CEO file, and it's going to look for a method called total compensation. Once it finds it, because it's going to find it because it's here, it's just going to run whatever code is inside, and it's going to do that. At this point, it doesn't even know that there is a total compensation method in the employee superclass. However, if I were to take this out by commenting this stuff out, when we run our runner file, it's going to hit this puts alley.total compensation. It's going to go to the employee file, not the employee, the CEO file, and like, okay, where's my total compensation method? There is no total compensation method. So it will then go to the next place in the lookup chain. In this case, well, in all cases, it's when the next step up the lookup chain is the superclass. So what is the superclass of CEO?
Employee.
So we're gonna go over to the employee class, and it's like, okay, employee class, do you have a total compensation method? It does. And so when we do that now, it's going to run the contents base salary plus bonus. But here's the question: what happens if it doesn't find an employee?
Looks for it higher up.
Higher up. And so I don't remember off the top of my head, but let's do a pry require. Ugh. There we go. Just going to copy and paste this. Cool. Class is CEO. If it can't find it in CEO, it's going to go to its superclass. So which is superclass is employee. It's going to look, let's say if it doesn't find an employee, it's going to look up in that superclass, which is object. If you can't find it there, it's going to go to basic object. Basic object is the end of the road. And if you can't find there, it'll come back with an error says it can't find it. Can't find it anywhere. We've looked literally everywhere. Cool. Cool, cool. Let me resize my windows a bit. Where are my notes? Okay. Things to be careful about. When you're just working with a couple classes. Let's say you have a project and you're just working with dogs and cats, right? Do we really want to make an animal class if we just have the dog and the cat? I'm like, I'd probably not. I think the overhead of like having to go over and make an animal class and figure out what inherits from is kind of, it's work, right? It's just like this extra thinking that I have to deal with. And usually a good idea is that when we're just working with a few objects, a few object types, it's okay to have that little bit of repetition there. Don't think about using inheritance. However, as we go forward and as we go forward and realize that our application is much more complex in that we're going to have to deal with dogs, cats, birds, elephants, platypuses, narwhals, like you name it. Like at that point, I would be like, okay, maybe this is a time when we start pulling this stuff out and setting up this hierarchy, right? The big picture idea is that's easier to pull things out of a subclass and put it into a superclass than the other way around. And that is like, this is kind of like why when we're working in this kind of fashion, we should start off with like just like the basic objects first, like the specialized objects, and then think about that generalization later on as a refactoring technique, because it'll be easier to refactor that upwards than to pull things the other way around. Things defined in the subclass. The parent class needs. And we kind of touched upon this briefly when I don't recall who we were talking about, like, well, this base salary and bonus, like, what about the intern? Like, what if I tried to access like this, if I didn't have this and if I didn't have this here, I hit total compensation, like this would error out, right? And the idea here is that another child class may be created that doesn't give us a base salary or bonus, but then tries to hit total compensation, right? And that's not great because it'll error out. And so Sandi Metz recommends doing something like this. Nope. Nope, that is not what I wanted to hit. Defining these here so that when we're trying to access base salary and bonus, if it can't find them, it'll raise a not implemented error. Let me wind this out a little bit so you can see a little better. And this is a pattern you can use if you do get into the situation where your superclass defines on attributes that may or may not exist in your child class. Cool.
Can you demonstrate how that works?
Yeah, so let's talk about it, right? I'm going to resize a little bit to make this a little easier to read. Yeah. So let's say we don't have a total compensation here, right? And in my code, I'm going to do Ryan total compensation. So Angela, you asked that, right? What happens first? Where is Ruby going to look for my total compensation method? Where's the first place it's going to look for?
So Ryan is
An intern.
In the intern class.
Right. And we see here in the intern class, do we have a total compensation method?
No.
Cool. So where's the next step?
It'll
What's the next link in the chain?
Inside employee.
Employee, right? Which we have over here. And we see total compensation. Great. That's fantastic, right? So it's going to look for base salary. What is base salary?
So it's a method, but the intern.
Is base salary, we see base salary defined anywhere?
Yeah, so like there, like inside total compensation, is going to look for a method called base salary, but we haven't defined one.
Not a method. It's going to look for the local variable base salary. Okay. Because we're inside a method, right? And if it can't find a local variable inside a method, what's the next step? Where's it going to look?
So, okay, so like if it's not a local variable, then it's going to check inside that same class to see if there's a method called
that. And what do we call that method?
Base salary.
No, I mean not the method specifically, but like the general term for a method that lives in the same class.
An instance method?
You're not wrong. Yes, you're completely right. It's instance method. I'm looking for another word. When things live in the same class, when methods live in the same class, what do we call them?
Siblings?
Yep, exactly. That's exactly it, right? It can't find the local variable base salary inside total compensation. So it is going to look for a base salary sibling method, which is here. And it's going to raise an error and it's going to say, hey, this does not have that information.
Okay.
So that is the windy path that we walk through.
I get like something that threw me off about that message that we print is the colon at the end, like what comes after. So this let's do this. Employee cannot respond to colon. Yeah. Require
intern Ryan equals intern.new let's do 10 Ryan ID 4 Ryan dot total compensation. Did I not save it? Nope, sorry.
You got to get in Pride, don't you, Mike? You're not in the Pride, Mike.
No, thank you. I'm like, what am I doing? See, this is what happens when you're trying to do stuff and you have like almost 30 people watching. Does it ever get less terrifying? No. And do I live in continual fear of doing something stupid in front of you? Yes.
Just think about McDonald's.
Yes. Oh, it's 10:41. That's when their menu has switched over to lunchtime service. I cannot wait. Yep. So it says, you can see here, it says not implementer this intern. This intern cannot respond to. ID is that this error message. This line here is what we're trying to say afterwards. So it's like, hey, we're trying to craft a little more user-friendly error that people can look at and like, oh, yes. I know that it cannot respond to employee base salary, line 15, employee line 15. It's here. Like, you can't respond to base salary. That's the idea.
So in your super classes, you would put in those flags for
Yes.
any
If
methods that you expect your child to have in case it
maybe not
doesn't have
methods,
it.
but like attributes. Well, actually, yeah. Essentially, those two are interchangeable, right? Attributes or methods. So yeah, this is a good fail-safe kind of. I think that in my own code, I would try to avoid situations where that happens. Like, because the idea is that like the intern is a like exception case. I try to figure out a way not to have the situation. I try to like take a step ahead of that. Yeah, like I would like, again, this is a kind of like how I would do that is that I would just have an overriding total compensation method in here. And I would not have to do this. But again, this is highly situational what you're trying to do. And so there are times where this is the solution. This is what we got to live with, even though like it just feels like having this here is a little clunky, but it is agreed to is like when you have to do this kind of thing, it is a best practice.
Mike?
Yeah.
Just as you said, when would be a situation where we might have to do this kind of thing?
When some employees, when some child classes have attributes or methods that the parent class depends on, but those methods may not be present in all children.
Mike,
yeah.
I can't see the bottom of your screen, even though it could before. What did it print for self intern? Huh. So that's also kind of confusing because it's inside employee.
Well, I would like, this would be my key. Like this is the thing I'm looking for. I think that when I see this error, I'm like, okay, base salary is the problem, and I know what line of code it is. But like this here is like, this is the error message that comes out. This is raising the error like this, creates an error message that looks like this, and it will tell you where and what method.
Yeah, I just wouldn't have expected self that class to output intern. I would have expected that to output employee.
Right, yes, but the idea here is that we only instantiate an intern object, not an employee object. Right, we're not instantiating an employee. In this case, like employee, you're never really going to create employee instances of employee. It's just like this bag that code goes into that is equally shared by its children.
Yeah.
The inheritance, if you will. Cool. Other questions? Cool. As we wrap this up, things to this is, I'm going to paste some links into your channel. This is a copy of Sandy Metz's Practical Object-Oriented Design. In particular, we want you to check out pages in Chapter 6. And in these pages, Metz talks about an alternative technique to using super. It is beyond the scope of this lesson. You do not have to do this unless you want to. It's very interesting. And other things that you can do is that you can, a lot of people have a lot of opinions about programming. And we suggest that you Google composition versus inheritance in Ruby for some more perspectives on when to use inheritance and when to use a module. Everyone has ideas about everything, and we are not advocating that one over the other. I think that is very important for you to see, like, the various opinions that we have. And finally, there is a CFU, if I can ever find the link to it. Just have this done probably by the end of the day.
Hey, Mike, if I was going to like write a test, if I was going to write like a test for the employee, where would I find the information to get like the total compensation?
You would not test the employee, the employee class specifically. You would test it through the child objects.
Okay.
So like, I would spawn out a. You would want to test all methods in the employee superclass in every single child class. So like I would want to test total compensation for the intern, total compensation for the CEO, total compensation for the sales manager.
So employee then would just essentially test that it exists and test that it has attributes, a name.
I would not even do that, because like you are not ever going to instantiate an employee object on its own. You'd be testing it through the child objects that inherit from it. Cool. Awesome. That is it for today.